Hey everyone, happy day one of distance learning. Now, I know today we are doing some topics that are review for most of us. I just want to make sure that these are topics that we are familiar with and understand before we get into the next topic. So we're going to be reviewing slope and linear equations today. So first we have to say what the slope formula is. So we want to talk about slope in order to be able to write those linear equations next. So the slope formula we've talked about, that's our change in y over our change in x. Now we write that as y2 minus y1 and x2 minus x1. So when we have 2 points, we'll have x1, y1 and x2, y2. So they're just the numbers that are in their locations in their coordinate point. And it's just saying that when I take my coordinate point, I want to make sure that I match up the same numbers from those coordinates. Now, I know some of you have done this where you do kind of that tunnel method. You take the difference of the two x's and the difference of the two y's. And so this goes on top, this goes on the bottom. And you would still get the same answer. It's just showing the formula, the equation that you are actually using to find slope. Now, we say slope is a special variable. We use the variable m to write slope. And we want to make sure that we are writing our answer in the most simplified way. So we're going to do a couple of examples to look and see how we simplify some of these things when they need to be simplified. What does that mean? Now, first things first, I'm just going to do a couple of these examples that I have on my sheet here. So if you want to do more of them, you are more than welcome to do that. However, I know that we have covered slope. A lot of you, this is review from last year or earlier on this year when we talked about it. But again, I just want to make sure that we know how to do this. So for our slope, we said that it's going to be m equals. And we have our x1 from our x coordinate, y1 from our first y coordinate, and our second point, 4, 3, x2, y2. And those little 1s and 2s, just like when we talked about with our sequences, they don't really stand for anything other than to tell us what coordinate point system we're getting that from. Now, to write this, we have our top and bottom of our division, and we're going to do our y's first. We want to do the rise over run. That's another way that we say slope. And on a graph, y is the coordinate axis that gives us our rise. So we would do 3 minus 1. And then on the bottom, we have our run, which is given by our x-axis coordinates. So we would have 4 minus 1. And we know 3 minus 1 would give me 2. And 4 minus 1 is 3. Now, I know that 3 and 2 do not have any common factors because they are both prime numbers. So this is going to be my final answer. For the next one, we're going to do the same thing. I have x1, y1, x2, y2. My equation is m equals. And again, we want that rise over run. So we do our y's over the x's. So we'll have negative 2 minus 4. And then on the bottom, 10 minus a negative 2. Now when I take a negative 2 and I take 4 more away, I'm becoming a more negative number. So we get negative 6. But when I have 10 minus a negative 2, you can think of it as either these two negative signs combining to make a plus sign, or two negatives churn each other positive. So 10 plus 2 would give me 12. Now, from the last one, we said these are two prime numbers. They don't share any factors because they don't have any factors. Whereas 6 and 12 do share a common factor. Their greatest common factor is 3. So when I divide 6 by 3, I would get 2, and it's a negative. And when I divide 12 by 3, I get 4. Oh, but that's not quite as simplified as it goes. We know if we look back that 6 actually goes into 12 an even amount of time. So I could have actually just taken a 6 out of here right away. Sometimes your numbers might be too big to notice that the greatest common factor would be 6, or maybe it would be 22. Whatever that number is going to be might be too big. So we just start small, start with what you first notice. And we know that this would become a negative 1/2. So that is our slope for number 2. Now I'm going to jump down here and I'm going to do 5 and 6 next, just to show you a couple of different examples. For number 5, we still have x1, y1, x2, y2, and our slope is m equals. Now our rise over run, or our y's over x, y2 is 9 minus 9, and x2 is 3, x1 is 5. Well, when I take 9 minus 9, I get 0, and 3 minus 5 would give me negative 2. Now for this one, it doesn't really matter what the bottom part of my fraction is going to be, because it's a negative 2 underneath 0. As long as it's a number that's not 0, we're good. So I have 0 on top. 0 divided by anything is going to be 0. So the slope for number 5 is 0. For number 6, we have x1, y1, x2, y2, and our slope m equals. Now, you can pause here, try this one out just to see what you get, see what happens. Now, I'm going to solve this by doing my rise over run. So I have my y's, 5 minus 8, over my difference of x's, so negative 7, minus a negative 7. When I take 5 minus 8, I get negative 3. And I said before, when we have a negative minus, that becomes plus a positive. The negatives cancel each other out here. But now I have a negative 7 plus a positive 7. And so those two would cancel each other out, and that is 0. Now, from before, I said it doesn't matter if we have a 0 on top. That's just going to be a 0. However, this time our 0 is on the bottom. You can ask Siri and she'll tell you why that doesn't make any sense to divide by 0. And so when we think of our slope, we would call this an undefined slope, or you can think of it as my favorite college that I attended. It's also the only college I attended, UND, undefined. And so we would describe that slope as an undefined slope. So this was our review of slope. I'm going to stop the video here, and you can check out the next video to see our linear equations and how to solve those. There will be a short post of this on Delta Math, so you can practice solving for slope given 2 points.